cars are moving around with defined speed. If any of the car is breaking the rule and having speed more than the defined speed, so what will happen? Either the person responsible for the duty should run after the driver, hey, halt, ruko, ruko, okay? And it is really infeasible and impractical to do such kind of tedious job manually, okay? And this kind of situation inherently demands automation, recognition of the number plate, so that even if it is violating without any notice, there will be surveillance camera, automatic alert message, warning message will be generated and go to the owner of the car, so that the rule will be maintained, and with of course the defined fine as per the prescribed rule, okay? So here if you see, identifying number is not a simple task, okay? Because you have to capture the image, identify, recognize the unique number, so that the data from the given database they can retrieve the owner of the driver, and SMS can be, or alert message can be generated. This kind of job normally cannot be done by conventional computing, because here is a matter of recognition of number, because many number plate have their own way or style of presenting or writing number in different fonts, styles, sizes, okay? And this is very difficult task to do manually. The person on duty responsible to catch the culprit, okay? So this is one of the situation where we need AI related application software, so that we can tackle the traffic properly. And this is normally done today, it is done manually, but it is possible to automate it completely, okay? So in order to solve it, we can use a machine to capture the number plate picture and convert it into text format and message, alert system, fine, etc., whatever the defined action is there as per the rule. The second image, if you see here, okay, there's a few curves, sketches, lines, okay, and still we can uniquely identify the person is Gandhiji among millions of Indians, okay. So what kind of computing it is? Can any conventional computer identify? Because there will be many people having the similar characteristics. Still we can recognize this person uniquely as a Gandhiji. What kind of computing demands this to recognize such person uniquely? Okay, that is one situation. And the third and last situation is this. Here, if you see the the picture, the target object have been mixed with the background noise. It is a noisy gray level image. And here if you follow some dog-like creature moving its head toward ground, maybe eating something or smelling something. There is a shadow of a tree nearby, okay? And can we recognize the object as a dog by conventional computing? Obviously not, okay? So this kind of recognition demands special kind of computing, basically enabled with AI or machine learning, okay? So to deal with such kind of situation, we need some additional computing requirements that may fulfill to recognize the target object, okay? This is another example where recently NASA sent robotic geologists to Mars, okay? And you know, Mars is an okay, okay. Uh, uh, so far the people are not able to reach Mars, so we don't know the situation or constants over there. So live people, if we send people, they may die. So here what we are doing, we are basically sending an robotic geologist whose basic task is recognition, classification of the materials to be observed by the robotic arm, capture the sample and analyze it. So analysis point is not task of machine. Sensor can capture the sample, but decision cannot be taken. So to make decision to act like a geologist, we need AI-enabled systems to recognize, classify the samples. Okay, so this is the situations I have mentioned. It demands special type of computing, that is nothing but AI enabled computing. Okay, so actually, without going through the history, the presentation will be incomplete. So I have kept one slide collected from internet. The history of AI, it started from 1950s up to today, and there is a milestones covered in at each step. Okay, for example, Alan Turing discovered, created a test called Turing test, whether a machine can fool a man, okay, fool a man, How we'll be explaining this after a couple of slides, okay? To Alan Turing test to say whether a system is intelligent or not, because intelligence is very confusing term, okay? And later on in the history, in 1952, first computer learning program was available for checker games, okay, written by Arthur Samuel in the year of 1952. Later in the year of 1957, first neural computer was invented or proposed by the Frank Rosenblatt's perceptron model was proposed for learning. Okay, learning process was incorporated first time. Okay, simulated the thought process of the human being based on the working principle of human nervous system. Okay, and later on in the year 1967, first k nearest neighbor algorithm was written and implemented to classify an unknown object. Okay, and gradually, students of Stanford University invented the kart, which could navigate, avoiding any accident or obstacles in front of it in its way, actually, in the year of 1979. Okay, and in the year of 1997, IBM Deep Blue beats in the world champions on the world champions in chess. Okay, chess playing, and the machine win over the man. Okay, in the year of 2002, a software library for machine learning algorithms named Tor was first released. And later on in the year, uh, uh, kindly mute your systems. Okay, in the year 2016, okay, Google developed DeepMind is managed to win 5 games out of 5 in Chinese board game Go competition. So this was a very brief history of AI-enabled systems, and later on there are many other works I'll be presenting gradually in the successive slides. And with the last 40, 50 years, the hardware technology have matured in a tremendous pace, okay, and fulfilling the demand of high computing, conversion from CPU to GPU, and nowadays everything is high-end computing facilities are available in cloud with minimum cost. Okay, we can be and use the infrastructure. Okay, CPU based. So because as the computing demand increases, particularly machine learning or AI-related tasks, where millions of floating point calculation can be done within seconds or fraction of seconds, so that high demand can only be satisfied through the high-end computing processors. And TPU is tensor processing unit is nowadays available. So in this presentation, I will be trying to discuss to clarify the concept of AI, what is AI actually meant for, and what is machine learning, how it is associated with it, and its limitation as well, and how deep learning comes to the rescue of the limitations of the existing machine learning techniques, and some aspects of deep learning and its application. Okay. So let us proceed. So what is AI actually? Okay. Artificial intelligence is the capability of a machine to imitate intelligent human behavior. Means human perception, human way of thinking, way of decision making. Will try and mimic in the form of computing, and it give birth the subject AI. Okay. AI is accomplished by studying how human brain thinks and how humans learn, decide, and act or work while trying to solve a problem. And we'll try to mimic and develop a metaphoric engine so that similar kind of action can be taken by conventional computers. Okay. The outcome of this study is used as a basis for developing intelligent systems and softwares. So now, definition of AI, because it is there are so many definitions available in many books. Okay, some of them I have captured here. Here, computers with the ability to mimic or duplicate the function of the human brain, that behavior, and working and using it for solving real life problems. So, artificial intelligence is study of how computer systems can simulate intelligent process such as learning, reasoning, and understanding symbolic information in context. Look, conventional computing is based totally on the instructions given to it, okay, through the any particular language. But AI-enabled system, we have reasoning, learning provision, which is not present in conventional computer or any other conventional computing. Okay. So here is the test proposed by Alan Turing. It is a beautiful test to say whether a system is an intelligent system or not. What is that? On the right hand side, we have an opaque body. Just a minute. Okay, filter. We have an opaque body, and in the one side there is an interrogator asking questions, and opposite side of this curtain there are responder that responds to the interrogator. Okay, the interrogator asks this question to the responder and responder responses, and the responder is not visible to the interrogator, that is the person who is asking the question. Now if the interrogator asks a question and get the reply from the opposite end, and if the interrogator is not able to distinguish whether the reply is given by a system or a machine or a human being, then this kind of system is called intelligent system. Now, the communication may be textual communication, maybe voice communication like Alexa, okay. Oh, and it is very difficult who is responding on the opposite end, is it a man or a machine? And if we are able to provide such kind of system, that kind of system is intelligent system. Okay, so actually the behavior of a human being is captured through the system, and that is the objective of AI enabled systems. So here I have written the points here. The proposed by Alan Turing in the year of 1950s, a British computer scientist. Intelligent is defined as the ability to achieve human level performance in all cognitive tasks subsequent to full human interrogators. Okay. Okay. So now the test was devised in response to the question, can a computer think? The result was positive if the interrogator cannot tell if the responses are coming from a machine or a human. Okay, so that kind of test, if we are able to devise such kind of system, then we'll say it is an intelligent system. How? Let us have a demonstration. Here, Alexa, you are now familiar with it, is easily available in the market. Okay, but sorry, the video is not working. No problem. Basically, it is a device speaker along with microphone connected through your phone to the cloud, and on the real time we ask questions and the question is understood, captured and transmitted to the cloud. It is recognized and response is generated in real time, and it will be very difficult whether the response is coming from a man or a machine. So this is a beautiful example of intelligent system. Okay. So AI definition and differences from conventional computing. So AI is a branch of computer science dealing with symbolic, non-algorithmic methods of problem solving. That is the key differences, key points need to be understood. Non-algorithmic approach. Whereas in conventional computing, we have algorithmic approach. We have algorithm which translate in a language in the form of a program and through instructions, and it is executed the order it is written. Okay, and here, but in AI system, it is non-algorithmic method. Means we have no defined algorithm, no pre-program instructions there. Okay, still the system will learn through examples or samples only, then associates the input-output relationship and try to draw an analogy that if the behavior of the input is like this, its output will be like this. That kind of association is mapped or learned through examples. Okay, and if there is no mathematical model to solve a particular problem to discover the input-output relationship, AI, such kind of non-algorithm or model-less approach is the best way to solve that kind of problem situation. Okay, AI works with pattern matching methods, which attempts to describe objects, events, and processes in terms of their qualitative features and logical and computational relationship or association relation among the objects. Okay, so basically we are basically in the transformation phase from conventional computing to intelligent computing. And what is meant by intelligent, I have just given the Turing test example. Okay, so what is it in a more elaborate form? Here, the idea is to model the cognitive behavior of human mind. It means we are expecting our system to be robust enough to behave just like the behavior of a human being. Okay, and it is a fundamental foundation of the conceptual intelligence in machines. Unlike conventional computing or hard computing, it is tolerant of imprecision, uncertainty, partial truth, and approximation. So it can deal with imprecision data, imprecise data, uncertain data, and even partial information based on partial truth or data or partial information. It can decide and approximate. Okay, I can. It is different from conventional logic in the sense that it is not a threshold-based logic. What is threshold-based logic? Suppose that we have defined two categories of people: short people and long people, means tall people. Okay, so tall people, how to define? We have to define some threshold in threshold for height. Okay, suppose that any person whose height is more than 5.3 inch and above will be treated as a tall people, whereas below 5.5 feet and 3 inch will be treated as short people. So in any conventional computer using if then else logic, we can easily classify, okay, based on the threshold value. But think about a person whose height is 5 feet and 2.99999 inch. Oh, okay, the 1 million times zero point 0.1 inch difference, it is almost equal to, not theoretically equal to, but practically 5.2 uh, 5.2 inch and 0.99999 inch is almost practically equal to 3 inch, but it will be treated as a short height person because it is violating the threshold of to going to upward. But if it is intelligent system, it will not discriminate such kind of hard boundary. It will that person will also be treated as tall if you are using such kind of cognitive computing. Okay, because it behaves the way human being acts. Unique features. It is an approach for constructing systems which are computationally intelligent, possess human-like expertise in particular domain, and can adapt to the changing environment and can learn to do better. Here, the fundamental thing in the last point is that in a conventional computing, for the same input from the same algorithm, you will every time you run the algorithm or program, you will get the same results. But in case of intelligent computing, or the output will may vary. Okay, every time you run, you may come up with different output. Okay, but not the same output. It may come same, but different options is obvious also as well. Okay, and that is the key features. Sometimes we are confused with machine learning and AI. AI is a broad field or broad areas where machine learning is a subfield of AI. And if you focus on deep learning, it is a subfield of machine learning, and machine learning is a subfield of AI. AI is a big domain, or this machine learning is a subdomain or sub areas, and deep learning is sub areas, which falls on is a subset of machine learning. Okay, for confusion, because many people confused with the topic. Okay, that's why I have kept these slides here. Machine learning we are talking about. So basically, there are three types of paradigms used in machine learning. It is supervised learning, unsupervised, and reinforcement learning. Okay. In case of supervised learning, there is a teacher who has the complete knowledge about the environment where the system is embedded, and system learns the environment and by interacting with the teacher, and when the domain knowledge about the environment of the teacher is transferred to the system, then we can dispense the teacher and let the system work directly with the environment without any intervention from the teacher. Okay, that kind of situation paradigm is called supervised learning. In case of unsupervised learning, there is no teacher at all. Okay, there is environment and the system itself, and the system interacts with the environment and have some statistical measures, task independent measure based on the distribution of the data, and decides or groups it and concludes. Okay, in case of reinforcement learning, it is basically agent-based system. There is an environment, there is an agent. Okay, and the agent take action. That action may be good action, bad action, and if it is good, it is rewarded. If it is bad, it is punished. And when by trial and error method, repeated trials, when the score or award or reward will be increased so that the system becomes stable. And many real life situation can be suitably modeled using reinforcement learning. For example, learning cycle riding, how to learn cycle riding, how to learn swimming. Okay, by trial and error method, you come to understand the philosophy of balancing the cycle or balancing yourself floating on the water. Okay, and that kind of learning can be modeled suitably using reinforcement learning. We will be discussing some aspect of supervised learning and mention few points related to others as well. This is the slide I have already mentioned. The environment where the system is supposed to work. Teacher is nothing but a component that has domain knowledge about the environment. And learning system basically a system that will work or interact with the environment. Okay, and it is a continuous process. During training process, the environment interact with the learning system, and there is a observation of the teacher or monitor, and the learning system can take response or can act. That action may be right or wrong. The teacher instructs to rectify the action, and in this way, a continuous interaction with the teacher about the environment is goes on. And when the knowledge of the teacher about the environment is completely transferred to the learning system, we can dispense teacher means the learning system can work directly with the environment without the help of teacher now. Okay, that kind of teaching. And in practical situation, data situation, supervised learning basically label data concerns. The learning system is the model you propose, and the data environment is nothing but the problem, the data situation, classification problem we are dealing with. We supply the feature of the samples about the environment, about the problem to the system, and the system decides whether it is correct decision or incorrect decision, and the labeled output act as a teacher to say, no, your output result is decision or action is wrong, so rectify it, and also mention which direction to update the parameters of the systems so that it can perform better next time. Yes, in this way it works. Okay, so artificial neural network is a paradigms, okay, based on the human nervous system where the basic unit is neuron, and the connectivity among neurons forms the network topology. And learning algorithm is how the knowledge is updated, how the knowledge of the environment is acquired through the process of training. Okay, so in artificial neural network can compute any computable function by appropriate selection of the network topology and weight values. No, here weight values is the knowledge. Okay, a particular weight vector basically gives the mapping from the input to output domain. Topology is nothing but the connectivity or architecture of the network. It is how the neurons are connected. So if you change the topology or connectivity, the network model will change. Or if we change the algorithm of weight updation, then the network will change. Okay, the model will change. Okay, and it learns from experience, specifically by trial and error method during training. Okay, each sample will take several cycles or epochs to and fro unless or until the sample is recognized by the model by mapping it to the desired output class. Okay, so this is the illustration how you can understand, because human learns from past experience, whereas machine is totally instruction based. Okay, pre-program based. It follows blindly the instructions. Now our expectation from a machine is to behave like human being. Okay, so what if human can train the machine? This is possible if you keep some provisions so that we can train the system. We'll keep provisions so that from example the system will learn the mapping or association from input to output. Then it will be easier to recognize any unknown sample to map its proper output class as per its input feature distribution. Okay, and the objective here actually is to train the model or keep provision to train your system so that it can learn through examples. This is another example where many people listen to music. Suppose Paul is listening to song. So song can be song is of different quality. Okay, some are having high tempo, high genre, high intensity or low intensity, and it may be male voice, female voice, gender of voice is also important. Suppose Paul is like certain tempo and genre as shown in the next diagram. So Suppose the green one is the liking of the Paul and red one is disliking of the Paul. Here two parameter, music parameter have been considered in the X and Y axis, that is tempo and intensity. Okay. So based on the tempo and intensity, the taste of the Paul, if it is plotted, the upper circles indicates the liking music of Paul and red one is the dislike music of Paul. Okay. Now if there is a music, okay, say A as shown here, A is the music, whether it is to be liked by Paul or not. Okay, so if you follow it and you see that it is the liking domain of Paul, so definitely the unknown music A will be liked by the Paul, you can predict. Okay, now think about a situation. So A song will be liked by the Paul. Similarly, think about a situation here, this point, whether that music B will be liked by the Paul or not. How to decide? It is not falling in any of the inside circle or semicircle. Okay. So now what is the way how to decide about music B whether it will be liked by Paul or not? Okay. So a very simple strategy is draw the distance from each of the centroids and which one is the nearest. So the music will go to that category. So this is the motto or the machine learning comments using k nearest neighbor algorithm. So find the nearest neighbor and the sample is to be included in that neighbor and more. Okay, so in this way k nearest neighbor works. So definitely if it goes to the green circles, definitely the unknown music B will be liked by the Paul. Okay, and if it belongs to red, then it is likely that Paul may not like that music B. Okay, and here the main thing is that human being can learn using very few samples. It is so robust and so powerful. However, in case of for systems to do this kind of recognition, we need more and more number of samples to better fit the model and having higher accuracy, higher prediction rate. This is another example of supervised learning. Here, there are different currency value of different coins. Here, for example, rupees 1 is of 3-gram coin, 1 euro maybe 7-gram coin, and 1 dirham maybe 4-gram coin. Okay, so here we capture the weight as a feature and currency as a label. Then a machine can detect only by weighting the coin, and it can say it is 1 rupee coin. Now, weight is may not be exactly 3 gram, it may be epsilon amount plus minus with 3 grams. Still, the system will be robust enough to decide whether it is 1 rupee coin or $1 coin. Okay. Now come back to the theoretical aspect, how it is modeled. In the right hand side, you see there are several types of flowers. Okay. The species of flower prediction. So normally there is a one famous data called iris data, okay, where there are three categories of flowers, okay, setosa, virginica, and multicolor, and each flower is having four feature captured: safer length, safer width, petal width, as mentioned in the tabular form. And in this data there are 150 samples having four features of each, and they are mapped basically into three groups: Setosa, versicolor, and virginica. Okay, three class levels. In this way, so here the safer length will vary within certain range, petal length will vary, and okay, safer width will vary, petal width will vary. So based on the four parameters or attributes distribution, we have to map into three categories of flowers, whether it is virginica, versicolor, or setosa. Okay, so here, so how to train your model? Suppose this is your model. So you take say 10% to 20% sample, one sample at a time, and apply to the simple system and train the system that this is the sample of this group, this is the sample of this group in this way. When all samples are supplied to the system one at a time and train the system, now there are remaining 80% samples or 90% samples. And you take any one of the sample and supply to the system and ask the system to predict, and it will predict the sample correctly. Okay, almost with 99% 99 accuracy. Okay, so here, although the system was trained with few samples, say 10% samples out of 100% samples or 20% samples, because number percentage of data will for training will vary application to application. If it's image data, image database, image recognition, or face recognition, you need about 65 to 75 even 85% samples for training only, and remaining 15 to 20% sample for testing only. And for this kind of data, iris data, which is a well separable data, only 20% training data is enough, and still the system can predict unknown 80% samples with 100% accuracy. Okay, so in this way it works. So here neural networks basically works in two passes. Okay, in the during training phase, what happens, we apply the input data to the network or to the model, and the model predicts. Okay, the prediction may be correct or incorrect. So now if it is incorrect, there is an error that is due to the wrong choice of the network parameter, particularly weight values. Okay, then in the second pass, basically it is in backward pass, we update the weights in such a way that the mapping from input to output will be proper, and this to and fro process continue. Each process is called epoch. Okay, epoch, and each training sample will move or cycles to forward and backward direction finite number of times, maybe 20 times, 30 times, and this is called epoch. And when the connection becomes stable and input is correctly mapped to the output as the predicted class, then the training for that sample is over. Take the next training sample. However, the number of training data, order of training data, okay, is also important for training. Okay, sometimes people confused with classification problem and regression problem. Basically, classification will be on discrete values, like whether tomorrow will be hot or cold. Okay, true, false, yes, no, like that, positive, negative, or multi-class classification also permitted. However, in regression, we predict the continuous value. What will be the temperature of tomorrow morning? Okay, that kind is numeric value, continuous value prediction. So that is a small difference. Okay, now we have multi-class problem as well as multi-level problem as well. For example, in multi-class problem, multiple class, for example, cloud class or star class or moon class. Okay, so based on the image, we can classify. So 001 means it is moon, 100 means it is cloud is present, and 010 means sun is present in the sky. Okay, so this is multi-class problem because multiple classes are there. But in here, in a single sample, there are multiple level classes. Means both cloud and sun is present. So it will respond 101 means both cloud and sun is present, like that. Only moon is present, so only moon will be output will be 1, or other output class it will be 0. So this is multi-level classification, and the first case it is multi-class classification. So there will be no confusion. So far we have learned, we have input data. It may be wave data, maybe sound data, voice data, biometric data, image data, or numeric data, alphanumeric data. Okay, what about the kind of data? Okay, we are supposed to supply to the proposed model, so that the model will learn about the distribution, input to output distribution of the input samples, and accordingly it will learn the association of the input to output relationship, and it will predict the value based on the given input data. Okay, so far we are discussing only supervised learning. Okay, so supervised learning is where you have input variable as independent variable and output variable is as dependent variable, and you will use an algorithm, not algorithm, a model basically, to learn the mapping function, that is from input to output mapping relationship. Okay, so during training phase, we give the data as we learn in the step 1 learning. When it is learned, we have the model. Now on test data, we can predict whether it is a hit or it is a miss. In step 2, it is testing. Now testing can be this same thing I have mentioned already. Just have a look. I have already explained these slides. Okay. Now, how to measure the goodness of a classifier, whether the classifier is working properly or not. So you are basically having an algorithm model, trained model. Of course, they are well connected, and the association, that is input to output relationship, have been properly mapped. You will get the output. Okay. Now, any unknown data, if not trained used during training, if we supply to the system, it will map to its output class. That output may be a hit, may be a miss. It can correctly recognize the class level or may incorrectly recognize the class level. So how to quantify the performance of a system? For that, we need to build a confusion matrix. Okay, confusion matrix for two class problem, it is 2 by 2 matrix. Okay, so suppose we have two class problem. Okay, positive class or negative class. The samples belongs to positive class and samples belongs to negative class. So now take any unknown sample and ask the system to predict its class. Okay, although you know that because it is test data, level data, you know the actual output, but the system do not know. So now let ask the system by supplying the input features the whose class it is. So the system will predict a value that may be a hit, maybe a miss. So based on that, we measure it. For example, if actual output is no and predicted output is no class, there are two classes, yes, no class. So the counter of the corresponding entry will be increased by a plus plus. Okay, and if it is not recognized and if it is misclassified as yes class as predicted value, so its corresponding counter will be increased b plus plus. Similarly, if actual class is yes and the system predict it as no, the corresponding counter C will be increased. And if it is correctly recognized as yes class, yes and predictable yes, then its corresponding counter D will be increased. In this way, A is the total number of samples correctly recognized as no. Similarly, D is the number of samples during testing, okay, which is correctly recognized as yes. Okay, so here the recognition will come this value A plus D by total number of test sample used here, A plus B plus C plus D into 100%. Okay, so in this way, this matrix has been generated for a particular problem. So confusion matrix give you indication about the performance of the systems you have developed so far and how well it is performing. If the recognition rate is 100%, it is the best classifier. Another way of defining a problem, suppose all are best, which one is good? So a good classifier is good if it uses minimal training data to recognize all the unknown and data with 100% accuracy of prediction. Okay. In this way, we can measure or quantify the performance of a system, how good or how bad they are. Okay. Now, so far I have discussed about level data, that is supervised learning. Okay, there are other paradigms actually. Unsupervised learning, okay, is the training of a model using information that is neither classified nor labeled. Okay, and this model can be used to cluster or group information, the input data in classes on the basis of the statistical properties or similarity property. Okay, so in case of unsupervised learning, we are basically having clustering based on the similarity of the samples and group them, and we have high intra-class similarity and low inter-class similarity, of course, for a good clustering. Okay, so here is an example. We have some statistics about the performance of a test cricketers. Okay, if we train a model and if we plot the wicket versus runs, we may come out two types of groupings. Okay, the grouping of batsman and grouping of bowler, because wickets, if there is more wickets in the score of a particular batsman, okay, then run is less, not so good. For so you can group two group, we can have two groups, one indicating the score for batsman, one for the bowlers. The labeling, it is not labeling, you are identifying the group as per your choice. Okay, now another type of learning is reinforcement learning. Okay, which is learned by interacting with the environment by trial and error method, the way a child start walking, learning walking. Okay, here in reinforcement learning, there are agent and environment. Okay, the agent interact with the environment and take action accordingly and change its state. Okay, the action may be positive action, negative action, means the action may be good enough or bad enough. Accordingly, it is rewarded or punished. Okay, so an reinforcement learning agent learns from the consequences of its action sequences rather than from it being taught by a teacher or teacher. Okay, it selects its action on its past experience only, that is exploitation, and it is also new choice, that is exploration. Okay, and this every time it takes an action, it changes its states, and the action is rewarded or punished accordingly. And the objective of the agent is to maximize the reward point and when the stability reaches, then the learning is over. Okay, there is an actually the video is not working here. So here one player I have shown here with a robotic arm on the opposite side of a table tennis player. Okay, and here, the rotating arms captures the movement of the ball, its trajectory, and places its coordinate, its arm, such that it can respond to the player. So that player can interact with the robotic arm automatically. Basically, the robotic arm is equipped with a high-speed camera which captures the movement of that ball and accordingly decides and take action and returns the ball to the player. Okay, high computing demand is required. However, this kind of learning is incorporated through reinforcement learning. Okay. Now, I want to summarize something here about the supervised learning, unsupervised learning, and reinforcement learning, of course. Okay. Here, in the normal cases, human interact with student. Okay. So this is supervised learning. Teacher instructs the student, do this, do that. In this way, you learn. Okay. And in case of augmented semi-supervised learning, there is a machine and of course human being. Teacher is there augmented with semi-supervised learning as well as human and semi-supervised learning where level data are given. Okay, sorry, sorry. Okay, okay, okay. Machine learning. In case of reinforcement learning, the machine interacts with the environment, of course, with some assistance, okay, from the human being, and ultimately when learning is over we don't need the human component and still it will work. Okay, and machine, in case of unsupervised learning, there is no human being, it is totally environment and the machine itself and task independent measures, statistics, etc., so that they can find input output relationship. Okay, now there are some limitation of machine learning. Still, the domain is not completely matured. We can't achieve 100% accuracy as done by human being. Okay, particularly in natural language processing. Okay, cannot solve crucial AI problems like natural language processing, image recognition, character recognition, signature recognition, voice recognition with 100% accuracy. Okay, it is not useful while working with high dimensional data because it suffers cause of dimensionality problem where we have large number of inputs and outputs and samples as well. Okay, there are many limitations, and to some extent the machine learning, deep learning come into the rescue, but not totally, still totally not completely with 100% certainty. Okay, so one of the big challenges with traditional machine learning model is a process called feature extraction, because it is always all time open problem. Which feature are important, which are not. That decision making is very difficult. Even if we identify some of the features are important, but we can't totally be sure with 100% recognition. Okay, and for complex problems such as object recognition and handwritten character recognition, there is a huge challenge. And just imagine a situation where you are duplicating a check. Okay, if it is completely automated, okay, and forgery cannot be detected, then how disastrous it could be. Okay, so that's why we can't be 100% sure, cannot be depending totally on the system to do such kind of recognition task. Still manual intervention is required. Okay, deep learning model is capable to focus to the right features by themselves, requiring little guidance from the programmer. That is, to some extent, to some degree, we can free programmer from the choice of the feature selection. That is, pre-processing part is automated in case of deep learning, which earlier it was done explicitly by the human programmer. Okay, this module also partially solve dimensionality problem as well. So next, the idea of so we must understand what is deep learning. Okay, the idea behind deep learning is to build a learning paradigms or algorithm that mimic brain. Okay, and it is an improved version of artificial neural network. Okay, and here is the milestones of deep learning, starting from the earlier days theoretically, and nowadays we have practical tools available. So neural network was proposed in the year of 1943. After that, perceptual model developed in the year of 1957. In 1974 to 1986, back propagation algorithm, recurrent neural network, etc. Radial basis function network also developed. Okay, then concurrent neural network model, long short-term memory, bidirectional recurrent neural network, etc. developed. In the year of 2006, we have deep learning DBN model. We have ImageNet in the year of 2009, and AlexNet dropout successive versions comes out in the successive years, gain deep, etc. Okay, there's are perspective not so definitive historical record is credit. So why deep learning? Deep learning is scalable machine learning. Why scalable? I have shown here two diagrams. In the upper part of the line, there is one part where assume that it is a object detection problem. So we have input a car, and the system will detect it is a car. Okay. So earlier days using neural network, what we did, we pre-processed the captured image, scan samples, filtered it, applied feature selection techniques and other pre-processing techniques, and then the pre-processed data, filtered data is used for training purpose to the model for object recognition. Ultimately, we classify. Okay. But if you use deep learning, this component, human intervention as a pre-processing part, that is completely eliminated, which is taken care automatically without human intervention by the deep learning model. And in the deep learning model, there are basically three components: first layer, second component layer, and last layer. Okay, and if you see the performance, okay, amount of data as it is increasing, the performance of the system of the earlier system also decreases because of scalability problem. But if you use deep learning, so it is well scalable. Even if you increase the load or data, sample size, sample number, dimension, and volume, it doesn't matter, the performance will increase because we can supply the high computing demand by the TPU servers. So computing demand can be compensated and performance is not supposed to be compromised or degraded. Okay, that is the one of the main key distinction between deep learning and normal neural computing, because normal conventional computing have pre-processing component, manual component, which is manual component, whereas in case of deep learning we have automated component inherent within the model itself. Okay, and it is well scalable system deep learning model because because it is oil scalable system because the load cannot degrade the performance. Okay, so if the input performance increases, obviously the if the input data or volume of data increases, the curse of dimensionality is not going to hamper. Hence, the performance is not going to be compromised. Okay, you all know the deep learning neural network. The basic building blocks is neuron, and neuron is consisting of three components basically. Dendrites that captures the signals, cell body soma that accumulates the signal and propagates the signal through actions through synapse to the nearby neuron. Normally in synapse, okay, signals are connected. The other around 200 to 10,000 neurons are connected. So the routing information is still unknown how the information is follows the path to reach to the central nervous system. And the right hand side here we have shown the artificial neural network consists of the input layer connected through wires. There is a summing part that accumulates the signal, and firing function is there to transfer to the output. Okay, and basically it is based on biological nervous system. You are knowing. Okay, okay. Computational unit is neuron, and this is the artificial neuron. This is the natural biological neuron, and how this is forming a network. The right hand side in summary it has been written. Okay, there are the topology nothing but the connectivity of the neurons, and learning algorithm decides the way of weight updating rule, how the weights are updated during training, so that the input features can be properly mapped to the output. So that mapping actually learned through the learning process, and learning process is nothing but the updation rule. Weight updation is nothing but the knowledge updation. So once the weight become updated and become stable, the training is over. Now we can use the unknown sample to test for testing purpose. Okay. There are other key points here as mentioned. Key differences is mentioned here. The parameters human brain has around 10 to the power 11 neurons on an average and 10 to the power 15 connections. And only a fraction of the total memory is used, only 5 to 7%, as per the claim of the modern day uh, scientist. The topology in case of artificial neural network, it is layered structure, whereas human brains have no layers. It is asynchronous human brain. Still, the many of the functionalities of the human brain is not.
Heather, sir, you are being muted. Please unmute yourself, sir.
Oh my God. Is it okay now?
Yes, sir. Yes, sir.
Okay. How long are you as unmuted?
Just for 5 seconds. Just now.
Okay, so I can continue. I can continue from the slides, I suppose.
Yes, 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 sir.
Okay,
Sure.
okay. So topology in case of biological nervous system, it is asynchronous, whereas uh, artificial neural network works synchronously. Okay, and learning algorithm, artificial neural basically uses gradient descent method for learning, whereas we don't know exact way how human brain use which learning algorithm, still undisclosed. Okay, and power consumption in case of biological neural network, there are millions of floating point computation required for during learning process, which is as compared to the biological neuron, it is almost negligible. Okay, so there is a big difference with respect to power consumption point of view and storage point of view as well. Biological neural network usually have never stop learning, whereas artificial neural network stops learning after training. Okay, so there is a one dilemma called stability plasticity dilemma. Actually, what extent will allow a system to learn to the changing world, changing environment, and what extent will keep the old data undisturbed? Okay, so if you are continuously learning, that is exploring, then we can forget the old data already acquired so far. Okay, and if you do not allow our system to be learned at all, only during training phase only, what happens? What happens? Then we cannot adapt to the changing world. So a proper balance between learning with the changing world as well as keeping the old learned process, learned data, learn knowledge, not learn information. So we make to balance each of them. This kind of dilemma is called stability plasticity dilemma that indicates to what extent we will allow the system to learn and what extent we will allow not to forget the old data. Okay, and similar uh, 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 sorry. So here, simple neural network and deep neural network, I have drawn two diagrams. Normally, in simple neural network, there is input layer, output layer, and at least one hidden layer to solve most of the problems. Normally, in maths, we use two layers, okay, to solve the problem, any complicated decision problem. But in case of deep neural network, we have many numbers of hidden layers. And obviously, if we increase the hidden layer, the computing demand will be very exponentially increased as well. But we are least concerned because we have computing resources available to fulfill the demand. Okay, and here a complicated task can be easily mapped to the desired one because the discriminative power will increase by adding more layers. Okay, this is the so how deep is deep with respect to the hidden layers, number of hidden layers. That's why it is called deep neural network. It is a neural network, of course, based on the working principle. It's the same, but the computing, high end computing, is lies in the hidden layers. That is, we have many number of hidden layers: 7 layer, 9 layer, 11 layer, even more. Okay, so that is actually really adding the computing power, recognition power to solve complex decision bounding problem. Okay. So a collection of statistical machine learning techniques used to learn use feature hierarchy are often based on artificial neural network. So here, what will happen in case of complex decision making process? For example, if you are using any deep neural network and there are so many layers in the deep neural network, for each layer basically filtered out the search space of the input domain so that it can be precisely mapped to the desired desired one. So we have n number of images in a particular, sorry, in a particular input data. Now, as there is a progress through the layers of the hidden layer, the search space is reduced, getting reduced, and ultimately come back to the object of interest, that is target image. We can recognize whether Mr. X is there in the image or not. If you, such kind of decision we are going to make, then it is quite possible deep learning may be helpful. Okay, so here I have collected one slide from the internet. Okay, and on the left hand side, we have summarized the deep learning in one column. What is it? It is tags useful patterns from data. That is true, because pre-processing as well as recognition is there. That capability is there in the deep learning network model. How it has neural network and optimization technique, of course. Okay, how practically we have available tools and techniques, Python language, TensorFlow, and other. Okay, helpful. Hard part is good question plus good data. Okay, that is the hard part of deep neural network. Why now? Data, hardware, community tools, investment. Because the whole world is now moving around deep neural network application to solve complex decision problem. Because we have hardware technology available, how computing support high memory, okay, at low cost, okay, and high data are also available on net. So people are now easily attracted to this domain. Where do we stand? Most big questions of intelligence have not yet solved nor properly formulated. So still it is not completely mature domain. So we can do much more here. And on the right hand side, you have some application areas. TensorFlow is one of the model to be similar to the deep neural network model. Okay, it is basically a collection of libraries, open source, Python, available in Google. There are so many communities like GitHub available to solve and to help you. Okay, and there are so many software. Some are paid software, some are free software. And there are so many freely available things are available to explore your domain. Okay, and so many compatibility are there. One of the important problem, as I said in the discussion in the earlier part, that during training, three important aspects are the number of training data, order of training data. Okay, is important for training. Sometimes the representation of data can help to solve the problem in a more easier way. For example, here the data we have non-linearly separable. We need circles boundary to discriminate the items of blue samples and the green samples. But if we represent in polar coordinates, the same samples can be easily separable. Okay, so here they are linearly separable. Okay, so sometimes representation matters. Now the last part of my presentation. Uh, that is the application part. Okay, there are so many applications. Okay, from visual assistant to social media to financial sector, healthcare sector, e-commerce sector, and transport sector. And I have put a few slides here. Self-driving car for object recognition tracking on real time is challenging. Although it is available in current days, but only for inexpensive cars, which is not affordable by the normal public. Okay, and autopilot systems also. So automatic image caption generation is another challenging task. Voice control assistance is also challenging because we need voice recognition, expertise in natural language processing, communication, and solution in real time, and automatic machine translation where deep learning application is there. This is one of the conventional way of character recognition. Uh, Up to now, we have 87% to 90% accuracy. Okay, still not 100%. Okay, speech recognition. Oh, sorry, sir. 1 minute. हेलो हाँ सर, हम लोग को आज एक अर्जेंट सेमिनार बुला लिया, हम काल आएंगे वही 11:30 बजे, ठीक है? गेट पास नहीं मिला, काल आएंगे, ठीक है? ओके। सॉरी सर, एक अर्जेंट अननोन फोन आ गया, मेरा डेंटिस्ट के पास आज जाने वाला अपॉइंटमेंट था, लेकिन प्रेजेंटेशन टाइम हो गया। आई फॉरगॉट दैट वन। एनीवे, speech recognition and speaker recognition are two challenging domains. Speech recognition means what a person is speaking to recognize it, characterize as a token, understand it, and communicate it. Just like Alexa, it is a beautiful integration of several technologies like signal processing, voice recognition, natural language processing, cloud computing, etc., and done in real time. Okay, and image recognition still a child stage, I will say. Okay, sentiment analysis, fraud detection, e-commerce, and healthcare. There are so many applications. Okay, here booking of taxi, now Uber, it uses runtime okay, pricing, okay, based on the demand, number of cars available, bad weather, rush hour. Okay, interesting learning, machine learning model which is used by Uber. Okay, so it uses predictive modeling to predict where the demand will be high. Okay. Now, what can we do? Deep learning. So it is similar like input data, training system, learning system, and correct output prediction. And the input may be number, vector, sequence, image, voices, signals, anything else. It depends upon representation of the problem. Okay, it may be one to one, one to many to one, many to many, many to many. This is the healthcare application of machine learning and AI. Okay, here mind interpretation. We the patient is a paralysis one cannot talk. Okay, but she might or she might be thinking something, able to think but can't express. So if we have a brain reading helmet, what signal is going on, that is mind interpretation. So the decision can be taken by a system. Okay, and the action may be taken by the robotic arm. Suppose the patient is thinking to drink some water or something like that. Okay, but not able to express through voice. So by reading his mental state, okay, through capturing through the helmet sensor, EEG sensor particularly, EEG based sensor, still the robot can serve and fulfill the patient. This is a beautiful application. Remote surgery, air transportation, okay, autopilot system. There are so many applications of AI and machine learning. Pattern recognition, handwritten character recognition, okay, face recognition, speech recognition, speaker recognition, then surgery, robotic surgery, okay, surgical robotic system that can do delicate brain surgery, also enabling physicians to manipulate tools at microscopic level. Okay, biometric recognition, voice recognition, and written character recognition, signal processing. Okay, so many application, object detections. There are so many applications. Okay, target detection mainly used by the defense and used in defense. Okay, to destroy the tanks or any other objects of the enemy. Face recognition, face detection, criminology. Okay, etc. Aging, facial expression recognition, sentiment analysis, many others. I hope I am almost at the end of the discussion of my presentation. Okay, so there are a few more slides actually here. Data mining is nothing but mining of the data, you know. So there are many techniques like association rule mining, classification, clustering, sequential pattern, frequent pattern discovery, and prediction. These are the typical problems that are used. And if you change the data domain from numeric data to voice data, image data, biometric data, sound data, so the processing technique will change, the modeling will change, the representation will change. Okay, but the nature of the problem becomes same. So now the future of the AI. So the day is not far when you will just sit back in your cozy little beds and just command your personal robots to entirely do your jobs. He will be a perfect companion for you. Just enjoy the technology. That is the positive side actually. There are negative side as well. Okay. So now, before that, I will mention that some limitation or drawback of AI. It is of limited ability. It is not a general purpose system. It is highly specialized system. So each specialized AI-enabled system will do specialized type of task, not general task. If it is designed for face recognition, you can't use it for voice recognition. For that, you have to train it with voice data only. Okay, so it is application specific. Okay, slow real-time response because so many high millions of computing take place, so it is slow in real-time system. So not all everything can be solved in real time. So human system is God-gifted system which can do such kind of job with ease and intelligently. Okay, it cannot handle emergency situation if it is not trained properly. Difficult code to code because the provision to make generalized machine is very difficult. It is only possible for specialized machines with certain degree of accuracy, not 100% accuracy. And of course, it costs very expensive because आप आपका बूढ़ी मम्मी पापा को ओके एक ग्लास ऑफ वाटर देने में कितना एफर्ट बियर करना पड़ता है. Now think about this robotic arm I have just shown earlier. Which one? Just let me show you. Do you know the expense required to install such kind of systems? Robotic arm almost incur crores, and the decision making whole system etc another crores. Now एक glass पानी देने के लिए only to give a cup of water you need to spend 1 crore rupees. Now think about yourself who is serving to your parents. If you are serving your parents with a glass of water, how much cost it incurs? 5 rupees, 2 rupees, free of cost. That is the differences. Okay. Thank you for all for having patience. I am done with my initial discussion about AI machine learning. I have tried to give in the concept clear about the learning, particularly supervised learning, and what is AI. If you have any questions, you are free to ask. You are welcome.
Yeah, thank you, sir,
Most welcome.
for the nice lecture. So there are
Yeah,
some
please.
questions. The first question is, what is the difference between validating the model and testing the model?
Okay, good question. Look, normally we have three kinds of data. Training data used during training, test data using for performance measure. Validating is the way, it is a way of testing of course, but it has effects on tuning the parameter of the system, model parameter so that performance can be improved if there is any provision. That is the only difference. Validating is same as testing. However, through validating, the system can tune its parameter to improve its performance. That kind of advantage is there for validating a set, not during testing a set. I hope it is clear.
Sir, is there any special requirement for validation data set than the other data set, or it is the same as the
No. The
other?
way you partition your data, whole data into training data and test data, exactly same way validate data. The only thing is that you see the effect and tune it, see the effect in this way. What will happen? The best possible model parameter value can be chosen, which are tunable, which are adjustable through validating data only, not through test.
Sir, another question is, what is the difference between types of networks? I think the question is why we have so many types of neural networks.
Normally, neural network model varies. Basic unit is neural, no doubt. Simplified model of biological neuron, of course. But the model basically varies. I mentioned if the connectivity changes, the model will vary. The if the learning algorithm changes, the model will vary. So if any one of these neuron is same basic block, but connectivity if you change, that is topology if changes, architecture if changes, the model will change. Okay, and each model have their own merits and demerits. Not demerits, I would say. For example, half-field network can be used as an optimizer. Some model use as a classifier. Some model use as a preprocessor. So it depends upon the application of the particular domain. Okay, which model to use. Each model having their own specialization, own purpose.
Okay. Sir, the next question is, there are different ways in which the weights of a neural network can be initialized, like uniform method, and there are others. So, what is the preferable method for the same?
Okay, okay. Look, if you can randomly initialize it, no doubt, but it will take more time to converge. That is to reach to the stable connection for input output matching behavior capturing. Okay. But normal practice available in literature is to generate the random weights within certain bound, say -1 to +1 or minus zero point 0.5 to plus zero point 0.5, so that you can have minimum number of iteration for convergence. Otherwise, it will take more time to convert. That is the only point available in literature.
So next question is that there are many supervised learning techniques. So what are some of the other famous supervised learning technique and how to decide which one we should take at a particular time?
There is no magic or shortcuts. You have to go through the all modules and their applicability. Then based on the nature of the problem or which application you are dealing with, you have to choose. And not only that, you have to compare with other model as well, as so that you can claim that your claim is properly validated. There is no magic. You have to go through all of them and learn the subject, then only you can reach to that decision.
So the next question is, why is deep learning a data intensive technique?
Sorry, please pardon, please repeat.
Why deep a data intensive technique? And can we learn a deep learning model using limited data as well?
Data intensive technique.
I think, sir, the question is, why do we need too much data for deep learning? Can we use a small amount of data for deep learning techniques as well?
A good question, but if you can afford, you can purchase a system with rupees 5 only, why you will be bearing rupees 50 to purchase the same item? That is the answer. If normal neural network can solve a problem, while you will spend high computing resources to solve the same problem. I hope that answers your questions.
So this is it. And any other question from the participant sides? Anyone? Any queries? Uh, yeah. So the question is, how does a deep learning architecture extract the features automatically? Is it doing some
Then
kind of dimensionality reduction?
whatever is required, actually the if you go through the complete working principle of the deep learning model, you'll see there are three different distinctive layer. In the first layer, input side, there are some functionality taken care by particular component. Then in the deep relu part, you'll see some specialty. So in this way, gradually, it is not a magic. The pre-processing component is gradually filtered and rectified until or unless it reaches toward the output part. So it is automatically designed based on its working principle. You have to go through it to understand and digest and realize the working, the meaning of this.
So the next question is, sir, can you please tell us some black box ANN softwares, like I mean the basic users can use?
I have already kept in the slide. Okay, you just go through. I think Google is the best source to get such kind of information.
Uh, okay, I think, sir, this is
Python
it.
is a
Yeah.
I can share this slide where so many softwares tools are available is kept there. You can go through that one, okay, or you can get just ask the same question from Google. You'll get n number of links to get your information.
Okay, so I think we have reached to the end of the session. It was a really nice session, sir. A really nice introduction, the basics of AI and machine learning, because the crowd is really diverse and we need something that could be understood by all of them. So I think all the participants really enjoyed your session, and I am grateful and I thank you on the behalf of organizing committee that you took some
You are
time out
most welcome.
from your
You are,
busy schedule and give your precious time. So thank you once again, sir, from the Department of Computer Science, AMU.
thank you all for having patience to bear me. Thank you. Thank you very much.
And all the participants, they can leave now. And next session, the fifth session will start at 2:30. You are requested to join by 2:25 p.m.
Thank you. So may I leave now, sir?
Yeah, thank you, sir.
Thanks.
Thank you, sir.
Thank you very
Not, sir,
much.
sir. Thank you.